Good afternoon and good morning, wherever you are. Welcome to the next in our series of how to use APIs and Google BigQuery on dimensions. Today, I'm going to be taking you through how, or at least one strategy on how you can use dimensions on Google BigQuery to get comparative insights. And the example that I've chosen today is to do some benchmarking, because benchmarking is actually quite hard to do with the API. And it's definitely something you don't really get through the front end. So an example of benchmarking that I have in mind is for a given organization, what percentage of its publications are in the global top 1% of an FCR category, and then rank those together. So you get a ranking of their in institutions' top outputs. Or maybe you want to rank altmetric scores, or recent citations, or time cited. The approach is generally the same, and to calculate those rankings, one of the things you need to do is to obviously compare an institution against all the other institutions in dimensions, and that really is a thing that's really well suited to Google BigQuery on dimensions, because you can get access to all of the data sets all at once. So what I'm going to take you through is first an example of what that benchmarking looks like through the Google BigQuery interface. And then I'll jump into a Jupyter notebook to show you how you can use the same code as a utility, which reminds me I should share my screen. I'll do that. Christine, can you help me share my screen?
Yes, just a minute.
Awesome, thank you very much.
No worries.
Okay, so this is my very boring but very useful prototype benchmarking report that I have developed on Google BigQuery using the free tool that runs on top of it called Data Studio. So I'm just going to show you how it works and what the thought that I've put into it, and then we'll drill in from there. So I want to compare, for instance, all institutions for their output in the field of research category biological sciences. I'm looking at the year of publications in 2018. I'm looking at the top 1% of papers, and I'm only interested in institutions of a certain size. So to qualify for this ranking, if you like, you need to have contributed a weighted contribution to publications of at least 400. And by weighted, I mean if you're an author with another author from a different institution, the value of that publication to your weight is 1/2. So we're trying to get a sense of how much effort your institution is putting into a particular field of research category. I am going to choose the field citation ratio. I'm going to compare against all countries, and I'm not going to focus on any particular institution. So you can see for this example, not surprisingly, you've got the usual suspects up the top. So Harvard, Stanford, University of Edinburgh, University of Pennsylvania. And you can see if we look at the percentage of publications that they have in the global top 1% of output, it's for Harvard, it's 3.2%. So that's almost 3 times what you might expect if you just were assuming that maybe just 1% of your outputs would be in the top 1% globally. So, and you can see that that quickly gets down to 2 and falls rapidly towards 1 at about rank of 34. So it's hard to even get 1% of your outputs in the top global 1%. So that's nice. But what if you just wanted to focus on a country? Well, we can restrict that to country. And we do need to wait a little minute because my code is a little bit slow, I have to say. It's doing a lot, and we'll see what it's doing in a minute. It takes about 10 seconds to come back, I think. So I really am excited about Google BigQuery for this sort of thing, because you can immediately create benchmarks about it quickly. So now I've got a ranking of Australian institutions, looking through and in order of their percent of outputs in the top 1% in this case. Now, if I wanted to change the percentile, so I might look at the top 10% or the top 50%, all I would be doing would be changing the number, and I'd be getting a dynamic ranking. If I wanted to change the institutions that I were looking at, so perhaps maybe include smaller institutions, I could always put this cutoff down at say 20. Again, that take a little minute to come back. It is doing an awful lot. So the reason it's feeling a bit slow is that to do these calculations, it is reaching across the entire dimensions data set every time and calculating those percentage cutoffs for me, which is because they are a calculation. So just before we leave this screen, there is one more thing I want to show you, which is why I'm going to wait for this to return. Here we go. So this is great if you happen to be up the top somewhere, but if you are in the list halfway down, or if it's indeed if it's a global list, then you might want to just say, give me the 5 institutions above my ranking and the 5 below. And so if we wanted to say focus on an institution, say the University of Melbourne, and you can tell this is a prototype because all of my lookup values are only slightly populated. And what that's going to do is it's going to filter this list and give me the 5 above and 5 below. Through all of them, so I can see here, if I'm comparing universities large and small against the University of Melbourne and looking at the top 1% of their output, there are actually some smaller institutions that are well worth looking at, as well as the bigger ones. So that's one other useful thing that we can do. So this screen indicates the power of what you can do with GBQ. You can take the same approach for any of these metrics. So you can benchmark across different things. You can benchmark across different research categories. So there are 3 examples here. One is an SDG, one is research activity code, and one is obviously a field of research code that we're looking at. This was built in pretty much 2 steps. So if we go back to see how the form was constructed, we'll see the form is just this table here with a custom data source, and we'll jump into that in a minute. And everything that's on this form comes from the custom data source. So these fields here with the lookouts are parameters that go into my query, and here's my table laid out in Data Studio. If I jump back a little bit, I can actually have a look at the query, and this is where we're going to spend most of our time today explaining what this query does. So here we have it. So it looks a little large, but it's actually quite explainable. So there is a syntax in SQL, which is obviously what you use to query Google BigQuery, and hopefully you saw Michaela's excellent presentation a couple of weeks ago on just how to get things out of GBQ, because I'm building on that. But I like to use this syntax, so with, which enables me to build up my queries in steps. So for instance, the first step I'm doing here in this query is I am picking the publication IDs that belong to the category ID that I'm specifying as a parameter and passing to this query. And we'll have a look at the parameters in a minute, but they live, if you're using Data Studio, they actually, as you type them in, they appear down here. So we can see the category ID is just going to be an ID relating to one of the categories and dimensions. What's nice about the category IDs and dimensions is that no 2 categories are going to have the same ID. So you can create a single table, which is what this is doing. And so we've got a category ID, and we are looking for the research classification field that that category is in. So Because I don't know, it could be a field of research code. So that's why we've got this query here. So select pub ID and category ID from dimensions unnest the 4 first category level full, where the ID is in there. And if that's great, we'll get those. But it might be in the FOR second level, or it might be an HRA full one. So we've got to look through all of these different categories. There isn't a single table where you can look for categories in dimensions at the moment, but as you can see, a little bit of cut and pasting and you can get the data that you need. So I've got all of the pub IDs belonging to a category. So the next thing I'm going to do is, for those publications, I'm going to calculate the weights of each publication. So this is how much of that publication belongs to any particular institution or any particular grid ID. So here are my fields. I want the publication ID, the year, the name of the institution, its ID, the name of the category, the country that the institution belongs to. And then to calculate the weight, I need 2 fields. One, I need to know how many authors are on the paper. And the second thing I need to know is how many researchers that belong to that institution are on that paper. Now, obviously, this is a little rough and ready because not all authors on a paper will have a researcher ID or that belong to an institution, but it is probably the best approximation that we can get to. Over time, maybe others can suggest a better way of doing that. Okay, so that's what I've requested. So I'm going to take my pub IDs that I've got in the classification query up here, and I'm going to join them to the dimensions AI table. And that's pretty much the same as the way that Michaela was showing you last time, how you can join your own information to dimensions. In this case, I've specified the query inside this with syntax. So I'm joining my pub IDs to the dimensions publications table on ID. And then I'm going to get my authors from that table by unnesting the authors. And I'm going to get the affiliations from those authors by unnesting the affiliation addresses. And the final thing I'm going to do is I'm going to join the affiliation ID from the institutions and the affiliations to the dimensions grid table so that I can get the grid name and country coming up in the results. And I'm going to here restrict the publications that I'm looking at to things that have happened since 2015. That's not strictly necessary, but it did make my query run a little bit faster. So now I've got my weights. For every publication belonging to an institution, I now know how many authors belong to that institution and the total number of authors. So I can calculate, I can sum those up to get a total weight, and I'll do that in a minute. The final piece of the puzzle that I need is I need to get the publication metrics that I'm looking for. Now, because I've made this generic, I might be looking for time cited, recent citations, field citation ratios, or relative citation ratios. And all of these metrics, you'll notice, live in the same spot. So again, they're actually sitting in the dimensions analytics publications table, and they belong to a field called metrics. So in the publications, we've got a column called metrics, and inside that metrics column, we've got time cited, recent citations, field citation ratio, and relative citation ratio, which is excellent. Super convenient. We know where they are. They're just grouped together in a quite nice way. As well as that, we've got the alt metrics as well, and it doesn't live in here because it's got a slightly different syntax. And the reason it's got a slightly different syntax, I suspect, is because along with the altmetric score, Dimensions also stores the altmetric ID, which is fantastic because that means that you can use the altmetric ID to join to data that you might get from altmetric as well. So that's an excellent, excellent resource. Nonetheless, because it's got that additional piece of information, it lives in a separate spot called altmetrics, and you can get the altmetrics score out. And we can union these tables together so that depending on the metric that we've selected, and you can see the parameter is going to determine which one of these comes back, we can return this in our publication metrics table. So I've got my publication metrics, I've got the data I need to calculate the weight, so I'm going to pop those things together. So here you can see I'm now going to look at my publication cutoffs. I am going to calculate the weight as being institution authors divided by all authors. And I am now going to have a look at all those publications and work out which of those publications relative to a metric are falling in the top percentile that I'm specifying here. And I'm going to do that over each year. So if I happen to run this code over multiple years, I'll be able to create a ranking for, say, 2017, 2018, 2019. Okay, so I've got my percentile count, and this is another reason why using Google BigQuery is nice, because you get lots of SQL aggregate functions. So this is the first one we see here. We're calculating the percentile, and we're partitioning the data by year, which is super handy. So we've got our cutoffs now. So from dimensions, publication ID, and we're just joining the two tables that we've specified up here. And this is why you can see that the with syntax for writing SQL is actually quite handy, because you can break up your thought process into different tables. So for instance, my thought process was, let's get the publication IDs that we're looking for by category ID. Let's get the information we need to calculate publication weights for those publications and the institutions that they belong to. Let's extract the publication metrics. And now let's join those three things together so that we can get our information together. So we've got publication cutoffs. And finally, I need to pop that together so I can create some rankings. So here I want to create a ranking by institution, country, research category ID in year. I want to also count the number of publications that that institution has produced in that category year. I want to sum the publication weight, and that gives me my publication weight. I want to count the number of publications where the metric for the individual publication is greater or equal to the cutoff value that I have calculated in the previous table here using percentile count. And I want to calculate a percentage of the number of my publications that are above the percentage cutoff. And I now want to rank that data. So again, Google BigQuery has all of the lovely syntax that you can use in SQL. I say lovely, it's very powerful, but you do need to invest a little bit in time in learning it. So what we've got here is a rank function, and we want to basically rank our data over partition by year, so ranking within year. And the order of that ranking is using the count of the number of publications with a metric score higher than the cutoff, divided by the count ID, and we are going descending. So in fact, what we're doing is we're ranking by the percentage of publications for an institution that are in the top 1% of the category, or whatever the percentile might be. And finally, this is a little bit of extra stuff down the bottom, and this is because in that example where I wanted to narrow in on an institution and the 5 institutions above and the 5 institutions below, this is what this is doing for me. So it's saying for this particular institution in this result set, if I look at the 5 institutions above, partitioned by year, 5 below, ordered by the same ordering that I'm using in my rank, just give me what they are. So we're creating a list of those institutions. and we're calling that our grid window. Okay, so I've my rankings, and you can see that my rankings, these are the calculations above, and it's simply joining the tables together that I've calculated above. So we've got publication cutoffs, where grid ID is not null, and then we're just filtering our results to a particular country. So we might have specified a country, or because I've designed this to work in the interactive form, maybe I don't specify the company, maybe I just say all. And so this allows me to either select a country or select all, and I'm grouping by grid ID, name, country, category ID, and year, as I've said. And you can see here another bit of SQL syntax. Having grouped my data, I can restrict the results coming back, having the sum of the publication weight greater than or equal to the weight cutoff. So we're using it. That's where we use the filter to work out which institutions we're looking at. And we are ordering the publications, ordering by the, in this case, the size of the institution. Okay, and then we have our rankings table, and we can select whether or not we're investing in a particular ID or all institutions, and specify whether we want to get results out for a year or all years. All right, deep breath. That was a long query, lots of things going on, but you can see that just through methodically working through a couple of steps using a with statement, you can begin to build what is essentially a generic benchmarking query for Dimensions GBQ. And you can see that you can start using it, say, for instance, in an interactive dashboard, but you can also use it in Jupyter. And what I've done is I've created a Jupyter Labs notebook that does similar things. So why don't we have a look at that? And we can get a sense for how we might use this in practice. All right, so benchmarking with dimensions on Google BigQuery. We're going to authenticate, just as we do normally. So if I was running this fresh, I would run this statement. It would take me to a web page to give me a little token that I'd post back in, and it would authenticate my workbook. I'd load the modules that I need, so pandas, Google Cloud from BigQuery, very important, and matplotlib, because I like plotting things with matplot. And I'm going to load up data table as well. Okay, so a final bit of setup. So it's pretty important that obviously to set up your Google BigQuery account, it needs to know where to send the bill. And so in my case, it sends the bill via the DS Consultancy GBQ project. And we'll now create a client. So you saw probably in Michaela's examples a syntax of running queries that look like, I've probably got one here. Yep. So %% BigQuery, specify some BigQuery parameters if you've got them, and put the results in a data frame called, in this case, FOR categories. And then you can just run the SQL statement. It's super useful, super handy, super fast. But sometimes you need to put queries inside functions if you want to use them elsewhere. And so we are using the other syntax here, where we've been able to specify a client called client, not surprisingly. And just like we would with the DSL client, we're going to go client.query. So in this case, I'm defining a function called getBenchData. And you can see I've put some defaults in. So this is biological sciences, field citation, research. Just start with Australia. Look at all institutions, cutoff weight 400, publication year 0, which means look at all years, and look at the top, in this case, start with the top 5%. So my SQL, exactly the same thing as before. The only thing that's different is because I'm using it in Python, I've taken out the parameter syntax. So if you had a look at the same query over here, you can see that it's sitting with @category ID, and we've just changed that to the standard Python notation so that you can say, okay, we're going to put the variable category ID in here, which is specified in there. So instead of @ we've got curly brackets instead. So exactly the same query, pulling out the same things, and hopefully that makes sense. And now we can run our functions. So if I just want to use the defaults up here, which would be all institutions in Australia, field citation ratio, biological sciences, and I run that query. Depending on whether I've run it before, it'll come back quick like it just did, or it could come back a bit slower. So you can see for the publication year 2018, looking at Australia, we can see University of Queensland ranked first, Melbourne, Sydney, and Monash. So one of the things that I think is quite interesting to do is to tell a story about how those ranks change over time. So, which is one of the reasons I thought it would be useful to be able to bring back more than 1 year of data. So we're going to change that query up here, get benchmarks, so that instead of just bringing back 1 year, it's going to bring back all years. And this has this logic here. If I set publication year to 0, is what it's looking for to bring back all years. Because if publication year equals 0, then that condition is met regardless of what the publication year is. Lovely. And I'm just going to do one cheeky thing. I'm going to take my rank and I'm going to make it negative so that when I plot it, -1 is up the top and lower ranks are down the bottom. Okay. So if I can do that, you can see this is not a super interesting story. However, you can see that the University of Queensland has consistently played a role in excellence in terms of having the greatest percentage of its outputs. I think in the defaults, it was in the top 5% of its field. And you can see Melbourne mostly in second place, followed by the Sydney as well. Okay, so, and we can see what those benchmarks look like that we've just got, so that you can see the data underneath it. You can see here are the data points that was plotting for the University of Queensland, and you can see all of the rankings. So actually, for a lot of the time, not only is its ranking, is the University of Queensland's ranking quite stable, it's actually quite impressive that 7.5% of its output are in the top 5% of the world, which is quite excellent. Okay. All right, so that's for one category, but because we've got that function now defined, we can create a story across multiple fields of research, or multiple units of assessment, or multiple SDGs, or multiple RCDC categories, or multiple HRACs, or any of the other categories that are in dimensions. We can use this function to create a storyboard of what's going on. So first, we're going to get not one research category, but all research categories in the field. So we saw this before in our query. We're going to get the category ID and the name. And because there isn't a reference tables of categories in dimensions, we're just going to quickly get it from the analytics publications table. So you can see I am looking at the publications table and I'm unnesting the category for first level. See, I'm just getting back the distinct values. And then, because if I am looking at, so in this case, I'm going to tell a story about the performance of the University of Melbourne. And for each field of research category, there's likely to, well, there most certainly is going to be a different level of publication weight that I want the cutoff to be. And that's because Obviously, in parts of medicine, the number of publications produced by an institution is very high, and although an institution may be equally excellent in something like electrical engineering, the number of publications that engineering produces in a year is lower than that. So I need to adjust the cutoff of institutions that I would like to rank according to the field that I'm looking at. And so I am going to calculate the publication weights for the University of Melbourne, and then I'm going to use those weights. I'm going to say, for each of those fields of research, for the given weight of the University of Melbourne, I'm interested in ranking any institution that has produced at least half as much research as the University of Melbourne. So same logic as we saw before. We're going to get all of the publications that belong to the University of Melbourne. We're going to pick a reference here. In this case, I've picked 2018, and we're going to get the fraction of researchers belonging to Melbourne as a fraction of the authors, and we are going to sum up all that weight to create a weight per category ID. So we'll just do those two steps. And again, you can see how quick this is. This is a query that implicitly queries all of the publications in Dimensions and extracts the category IDs in super quick time. This is a query that queries all of the publications at Melbourne in 2018 in super quick time. So again, if you spend a little bit of time in the syntax of SQL and Google BigQuery, the rewards are quite significant. So now I've got my 4 weights table. I'll just write that here. And I'm just going to, from the weight that I'm getting back here, I'm going to calculate a cutoff. So you can see I'm just going to do it that way. So here's my tables now: category ID, weight, and cutoff value. So these are the cutoff values that I'm looking at for each of my scores. Lovely, and I'm going to do that. I'm going to extract out the classification. So I'm going to run my query over all of these classifications. Now I'm going to get a benchmark essentially for 12 different classifications in short order. We don't need NumPy, that's there for no reason. So I'm going to use matplotlib, and I'm going to use Seaborn to make my graphs look a little nicer. And I'm going to plot my results as a dashboard, if you like, or a matrix of graphs. So it's going to be a 2 by 6 set of graphs. So just working through that. For each of the graphs, I am going to get myself a classification, and I am going to work out what the cutoff was that I set, and then I'm going to run my get benchmark data function. So here across all years for the University of Melbourne with the adjusted weight cutoff and the category ID set. And now I'm going to try and graph that. So I've got to remember to invert my rankings so that number 1 is up the top. And I'm going to extract the data out that I need. So I'm going to pivot my data set around the name of the institution. It's going to be in the columns. The index is going to be obviously the year, and the values are going to be rank. And I'm going to plot that data. And so why don't I do that? Here we go. Now it's running quite quickly because I've run this before and the values are cached somewhere, but this could take maybe 20 seconds each to get the data out because it's doing a lot of work. So it's got the data, and now Matlib is just working hard to plot the data. There we go. So this is quite an impressive story now. So I've got a story of about the performance of the top 5% of University of Melbourne's publications as a ratio of its total performance compared to other institutions in Australia. So we've got a story for law, for chemical sciences, for medical sciences, engineering, psychology, information computer sciences. So you can see here medical health sciences, Melbourne, in terms of that top percentage output, has been doing very well through to 2015 and has swapped with UNSW Sydney, which has come up in terms of its high performing output quite well. engineering, there is just a raft of institutions that are doing excellent work in engineering. And the reason we're not seeing values up the top level, remember, is because I am looking at the, probably not remember because I didn't tell you this, I'm looking at the top 5 above Melbourne and top 5 below Melbourne. So if there are some smaller institutions in engineering that are doing remarkably well in terms of their top 5%, they won't be on the graph because of just the banding that I've been looking at. See a mixed story for information and computing sciences, fairly consistent story for psychology and cognitive sciences, and so on. So maybe top 5% field citation ratio isn't what you're looking at. Maybe you want to look at the overall performance of altmetric, or you want to look at recent citations. But this generic method will get you there for any metric, any research classification system that you're looking for. So that's really super powerful. And I think that's pretty much where I wanted to stop with this example. It was really saying, it was really a chance to give you an idea of what's possible to do with Google BigQuery that's, say, different from the Dimensions API, and really tease out some of its ability to leverage the computational power inside GBQ to give you something interesting. Now, going back, just thinking about the attributes of Google BigQuery that you could do to extend this prototype benchmarking example. Maybe you don't just want to filter on the size of institution. Maybe you want to use different data. So, for instance, I remember talking to a funder, and they were interested in a government funder. They were interested in comparing their country's research output, not with all of the countries in the world, but countries of similar GDP output to them. So just looking at more apples to apples. So you might want to use Google BigQuery to filter across to data at a country level on GDP. So instead of just being able to filter on country here, you can actually say GDP is similar to mine. Or another example, another client that we did some work for last year or so was interested in their performance compared to other institutions that were as young as them. So using some of the attributes on grid, for instance, year established, to be able to rank within institutions that were of similar age. And I think this really gets to the nub of where a ranking or a benchmarking exercise is different from a leaderboard, in that you can use the same data, and that same data will provide different rankings for different institutions, because different institutions have different backgrounds, different stories, and they want to be able to compare themselves against institutions that are in similar spots to them. So very rarely, I imagine, is it useful to compare yourself to Harvard or Cambridge or Oxford, unless you actually are Harvard or Cambridge or Oxford, because all of the implicit size and all of those benefits, esteem benefits, are unlikely to be present for your institution as well. So it's always about specifying and being able to control the benchmark that is most relevant to you. So that's what I am excited about, and hopefully what I've given you a sense of is that you can use Google BigQuery to create quite generic benchmarking code that quite quickly gives you powerful ways of constructing comparisons. So with that, I might just leave you with a little taster of something else I've been using Google BigQuery for, and this will be something we'll cover in a webinar coming up, but that's how to use Google BigQuery to quickly create, extract out network diagrams for an entire institution. So this is the University of Cambridge. Each of those dots we've been able to quickly classify the most prominent unit of assessment field that they've worked in across their entire career. And we've been able to extract out the network from 2015 to 2020. I think the Google BigQuery code for extracting all of that data took maybe 20 seconds to execute, and I'll be showing you how to use that information to construct network diagrams quite effectively to do that. And with that, I might see if there are any questions.
There are no questions so far, but feel free to add them into the chat box or the Q&A box.
Where did lost my little Cisco web thing? It's gone somewhere. Excellent. I bamboozled you all. But I mean, so first thing to say is this is our last session before Christmas. So I wish you a very lovely break, and I hope you have some well-deserved downtime. If you're like everybody else who's been working Flat Chat, you certainly deserve it. The second thing to say is that please stick with us when we talk about Google BigQuery and even the Dimensions API, because these tools really do have the power to transform the sorts of jobs that we do and the roles that we play within our institution. So they are super exciting, and they never stop giving in terms of what you can do with them. So looking forward to the journey next year to continue. Awesome. All right, with that, I bid you adieu, and we'll see you next year.
Bye, everyone.
Christine, can you help me turn my Cisco off? Can I get it back? Oh,